It's Stan Veit's History of the Personal Computer. From Altair to IBM, A History of the PC Revolution. By Stan Veit, Editor-in-Chief Emeritus, Computer Shopper. Copyright 1993 and 2015 by Stan Veit and A-Books Creativity Incorporated. Read by Randy Kindig, floppydays.com.
Chapter 6, Cromemco, Innovation and Reliability. One morning in 1975, Leslie Solomon, technical director of Popular Electronics magazine, entertained two visitors in his office who had designed some interesting electronic projects for the magazine. A more unlikely pair of collaborators you could not imagine. Roger Melen was an intense giant who stammered when he got excited. Harry Garland was a small, quiet man who preferred to listen, evaluating everything before speaking. Although opposites, they worked as partners for many years. At that time, they were graduate students at Stanford University and wrote electronic construction articles for Popular Electronics to help pay tuition. They had come from California to talk to Les Solomon about a TV camera project called Cyclops that they were designing for the magazine. Les Solomon's office was small and filled with electronic gadgets, so with three people it was quite crowded. The partners quickly noticed a strange piece of gear they had never seen before. "What is that?" said Melen, pointing to a blue, amplifier-sized cabinet with red and green lights and rows of toggle switches on the front panel. "It's a computer," replied Solomon. "It's the Altair. Watch this." Les started flipping switches on the front panel, and the lights changed as he worked. He was entering the tape loading program, one byte at a time. Soon the teletype went click, and Solomon started to feed a punched paper tape through the tape reader on the teletype. "I'm loading BASIC now," he said. After a few minutes, they were running crude BASIC programs and games like Hangman. It was enough. The partners were caught forever. On their way back to Palo Alto, California, they detoured and stopped at Albuquerque, New Mexico, to talk with Ed Roberts, president of MITS, who made the Altair. They had decided to go into business, developing peripherals and expansion boards for the Altair, and the first thing they had to do was buy one. This was not so easy because Ed Roberts was up to his neck with unfilled orders for Altair kits, and he wasn't about to just sell and deliver one to these two strangers, even if Les Solomon had recommended them. Solomon had been the one who acted as contact for the magazine, which had promoted the Altair with a cover story in Popular Electronics, and Roberts felt greatly indebted to him. But he really was in a hole for deliverable computers. In addition, Roberts wanted to be the sole developer of Altair expansion boards. The partners told him that what they had in mind was non-competitive with MITS and would greatly enhance the Altair, not merely expand it. The final clincher was delivered by the quiet Harry Garland, who convinced Roberts that someone had to design video and graphics boards for the Altair, and that they were the ones who could do it. They got the Altair, and upon their return to California, they formed Cromemco, Incorporated, taking the name from Crothers Memorial Hall, their dormitory at Stanford University. Their company was located in Stanford, and they called themselves specialists in computer peripherals. The Bitesaver. Remembering the complicated procedure Les Solomon had used to load the teletype and energize the Altair, Cromemco's first product was called the Bitesaver. This Altair-compatible plug-in board enabled the owner to program the new erasable EPROM, erasable programmable read-only memories, right in the computer. It used either 2708 1K or 2704 512-byte EPROM. The board could hold up to 8K of memory, and once it was programmed, it did not forget when power was turned off. It remained in the computer, and its pre-programmed memory could be used merely by turning on the machine. If the program had to be changed, the chips could be erased by ultraviolet light through a small window on the chip, and then be reprogrammed. The Bitesaver proved to be a very popular peripheral for the Altair and MSI computers, which were starting to appear all over the country. With it, a monitor program could be installed in the EPROM so that when the computer was turned on, it was ready to go. These days, we expect this kind of thing, but in 1976, it was a great advance in microcomputer technology. The Bitesaver was first advertised in Byte magazine in February 1976. It cost $195 in kit form, or $295 assembled, and included one 2704 EPROM chip. The TV Dazzler. The second board Cromemco made more than fulfilled the promise the partners made to Ed Roberts. It not only provided graphics, but displayed them in color for viewing on a color monitor or color TV set. It was called the Dazzler, and it used DMA, direct memory access. The Dazzler formatted each memory byte into a point on the CRT screen to give a 128 by 128 element picture. Its output was an NTSC signal observable on a color monitor or TV. Nobody had a color monitor those days except TV studios. You had to go through an RF adapter to feed a TV set through the antenna terminals. This might not seem very impressive today, with VGA color almost standard for PCs, but in those days it was like a miracle. Not even the largest mini-computer manufacturers had anything like the Dazzler. Cromemco provided not only the hardware, they made software available too. For only $15 a piece, you could buy a punched paper tape of the Game of Life in full color, Kaleidoscope in full color, or Dazzle Writer for alphanumeric displays in color. The Dazzler was built on two boards, but it only needed one connector on the computer motherboard. It cost $215 as a kit, or $350 assembled. Ed Roberts gave the Dazzler a big send-off at the first World Altair Computer Conference in March 1976. Cromemco's S100 boards. Living up to their slogan as specialist in computer peripherals, Cromemco developed a series of excellent plug-in boards for the S100 bus, as the former Altair bus was now called. Their products were noted for both innovative design and quality construction. Cromemco was not out for the quick buck as many other manufacturers were. Perhaps it's for that reason they lasted longer than most of the others. The D+7A analog interface board was one of the most important peripherals that Cromemco ever made because it provided a gateway into the world of scientific and industrial computing for the S100 computers. The D7+A was a high-performance board which provided 7 channels of 8-bit analog to digital conversion. This enabled input to the computer from control equipment which produced analog output. It also provided 7 channels of digital to analog conversion to output computer signals to analog devices. In addition, it had an 8-bit parallel I/O port to input and output data in digital form. It could perform the conversions in 5 microseconds, which at that time was lightning fast. Prior to the availability of the D+7A, the only methods of performing such conversions and controlling analog devices were through specially equipped mini-computers that cost 10 times as much as an S100 computer equipped with this board. The D+7A sold for only $145 in kit form or $345 assembled. Once we had this board to sell, I noticed a large increase in orders from universities and laboratories. Cromemco also improved the Cyclops optical data digitizer. It could hardly be called a camera, so it could be used for image recognition and process control scanning. Cyclops provided 32 by 32 pixel images using an f2.8 25mm lens. It needed a special controller to give software control of exposure time, frame rate, and memory allocations for picture storage. Although unbelievably crude by today's standards, the Cyclops was a beginning of the use of CCD devices for video imaging. This is how video cameras work today. The Cyclops sold for $195 in kit form or $295 assembled. Cromemco also sold a joystick to enable users of the Dazzler to draw images directly on the screen and provided the software to operate it. The ZPU processor board. The Zilog Z80 CPU attracted a lot of attention in the microprocessor world. It only required 1 voltage in place of the 2 required in the Intel 8080, and it could run at twice the speed. In addition, it had an enhanced instruction set, although it incorporated all of the 8080 instructions, and was a direct replacement for that older CPU. Technical Design Labs of Trenton, New Jersey had introduced an S100 CPU using the Z80. Digital Group had introduced a non-S100 Z80 CPU at the first Atlantic City Computer Show, but Cromemco felt it could be improved, so they designed their own Z80 CPU. Cromemco used the Z80/4 version of the chip, which was certified to run at the blinding speed of 4 MHz. Because most memory and I/O chips could not run at that speed, Cromemco provided a switch that allowed the user to select either 4 MHz or 2 MHz operation. In addition, the ZPU was designed to have power-on jumps to any 4K boundary. This enabled the use of automatic power-on operation of the computer. Today, we expect the computer to start up when we turn it on, hopefully, but in 1976, this was advanced technology. Even mini computers and mainframes needed bootstrap loaders and ILP loaders. Cromemco expected faster versions of the CPUs and memory chips, and so provided for jumper selectable wait states. This simplified interfacing with existing memory and I/O chips even while operating at 4 MHz. The ZPU was able to be installed in existing Altair or MSI computers, and it included the powerful Z80 monitor program at no extra cost. For those owning Bitesavers, the monitor program could be obtained in ROM for instant operation. This is equivalent to our modern BIOS chips. The ZPU sold for $295 in kit form or $395 assembled. The Z2 computer. Once the CPU was available, Cromemco took the next step towards becoming a computer manufacturer rather than just a peripherals maker. They bought a mainframe from MSI and installed their own ZPU, I/O boards, and memory boards. The famous red, white, and blue front panel now bore the title Cromemco Z1, and the performance was much improved. Of course, this was only a stopgap. Cromemco was hard at work designing a completely new type of computer. The new Z2 computer was housed in a massive square metal cabinet. It was said that circus elephants could stand on a Z2 without damaging it. It had a shielded S100 bus with 21 slots for the growing family of Cromemco plug-in boards. Tens of thousands of these Z2 computers were used for dedicated applications with the programs burned into ROMs. They still may be found in labs and factories all over the world, working away day after day, year after year. I doubt if any other computer has ever achieved the record of the Cromemco Z2, and I doubt if any ever will. With no rotating components, in addition to static memory and boards designed to last forever, the Z2 goes on and on and on. If you need variable programs, the Z2 could also be purchased with an 11 megabyte hard disk as the Z2 HD, or with floppy disks as the Z2 FD. The disk versions used the Cromemco version of CP/M called CDOS. The System 2 computer. The Cromemco System 2 computer was designed for use in a business environment or for general use. It had the same massive cabinet as the Z2, but it was equipped with two 5¼ floppy drives for a storage capacity of 780K. It used the same power supply, motherboard, and I/O boards as the Z2. The System 2 could accommodate up to 512K of RAM at a time when most business computers had from 48K to 64K of RAM. The System 3 computer. The System 2 was a very practical computer, but like the other Cromemco machines it looked like, it was designed to be installed in a lab or factory, not an office. Cromemco realized that it was losing the largest part of the business with its ugly duckling computers and set to work to design a business computer. The result was the Cromemco System 3, a very attractive computer built into a desk. It used either 2 or 4 8-inch floppy drives. To complement this attractive platform, Cromemco provided printers and video terminals that matched the design of the System 3. Dealers selling the system were specially trained and carefully selected. The System 3 used a CDOS operating system for single-user operation, but Cromemco also provided the Chromix multitasking multi-user operating system, a version of Unix. Cromemco also provided a complete range of software, including COBOL, Fortran 4 with the RAT4 preprocessor, 16K BASIC, microassembler, 32K structured basic, word processing, database, and graphics. Cromemco used the ill-fated Persky 270 floppy disk drives that caused processor technology and Alpha Micro such trouble, yet sidestepped the problems that afflicted other manufacturers who used the product. The Persky 270 had 2 8-inch drive sections using one motor and frame assembly. Processor technology incorporated that drive family in its Helios drive system, an unfortunate decision which loomed large in the demise of the company. Cromemco avoided a similar fate because it removed the heavy drive bezel, a piece that often caused the frame to twist, thus throwing the drive out of alignment. The System 3 bezel was part of the front panel of the computer and did not stress the drive. In addition, the usual Cromemco quality control negated trouble before it happened. System 1 computer. Not everyone wanted or needed a desk-sized computer system, so Cromemco developed a desktop computer with 8 S100 slots and 64K of RAM memory. It had 2 5.5-inch floppy drives, providing 780K of disk storage. It was able to run the complete range of single-user CP/M software and was clearly designed to compete with the North Star Horizon computers. A second model was equipped with a 5 megabyte hard drive. By adding extra memory as well as the hard drive, you could even run Chromix multi-user software, thus allowing several people to use the computer at once. System 0 computer. This model was practically the last Z80 computer developed by Cromemco. It was designed as a small footprint machine for use in labs where it would be operated by ROMs such as the Z2 was. For general use, a second chassis holding either a hard drive or 2 floppies could be stacked on top of the computer cabinet. What happened to Cromemco? Although Cromemco was one of the last S100 computer firms to go, it finally succumbed to the end of the 8-bit computer world for commercial uses. The entry of IBM into the personal computer market practically destroyed most of Cromemco's business, and in 1986 the company had massive layoffs because the business had been reduced to system maintenance and parts replacement. The company was sold and became the Cromemco division of Dynatech Corporation. Roger Melen and Harry Garland left the company.
Please look in the show notes for a link to the article Remembering Stan Veit. Join us again soon for another chapter from Stan Veit's History of the Personal Computer.